Yo, what is up, guys? Welcome back. Today's Monday, episode 12. Yeah, we're going to do another video today. Might be a shorter video today. I'm not really too sure. We'll just kind of see where it goes. Let's let's jump into our Pokemon of the day. Played a lot of Pickle yesterday, man. I was going to was gonna do some work last night, but I was just so tired that I couldn't. I had to lie down. My whole body hurt so bad. So sad, but it's okay. Right on. Let's take a look at the sound.
People always warn me about getting a credit card, but now I know better. SEFQ helped me pick out the right card and taught me how.
That's our sound. I don't even know how to do it, but we'll leave it at that. Yeah. Let's just jump straight into a Leetcode. Let's check out our daily problem. Man, are we gonna have it's like a hardcore domino week? Two types of tiles, 2x1 domino shape and a tromino shape. You may rotate these shapes. Given an integer n, return the number of ways to tile a 2x n board. Since the answer may be very large, return a modulo 10 to the 9 plus 7. In a tiling, every square must be covered by a tile. Two tiles are different if and only if there are two four-directionally adjacent cells on the board, such that exactly one of the tiling has both squares occupied by a tile. Two, four, two, 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 two. So we're doing all the different combos, right? In a tiling, every square must be covered by a tile. Actually, adjacent cells on the board such that exactly one of the tilings has both squares occupied by a tile. I think this has to be a recursion problem, or a DP one. Kind of out of it right now. That is equal to 3. Yeah, you know, I'm not sure, to be honest. I don't really know where to begin. I feel like the question's a little confusing too, but we'll leave it for another day. I'm kind of not really in the mood right now to solve something like that. Let's take a look at Leetcode's roadmap. Maybe take a look at another 2DP problem. Longest common subsequence. Given two strings, text 1 and text 2, return the length of their longest common subsequence. If there is no common subsequence, return 0. Some characters can be not and deleted without the changing relative order of the remaining characters. Given two strings, text 1, text 2, return the length of their longest common subsequence. If there is no common subsequence, return 0. The longest common subsequence. A subsequence of string is a new string generated from the original string. So we just finding this in this? That's what I'm kind of getting from this question. Like, is this in this? Oh, 1, 4, 3. Okay. Yeah, I'm kind of out of it today. Maybe I might only do one question today. Do this DP question. I can work on my project. Gives me time to do that. So. Okay. So my first intuition for this problem was to kind of put the longest string inside of a hash map and then check each of the values. But then I come to realize that it's based off order, right? And when we have this in a hash map, we have this in a hash set. It's not based on order, right? So I think that's why dynamic programming comes in here, but I'm trying to think, okay, well, how can we do this in this problem? How can we maintain order? I didn't even know if Linux had like a pane here, right? I'm trying to think here, like if we have, Jesus, A, B, C, D, E, A, C, E. Could we use recursion to keep track of, okay, we see A, we go through, we see C, go through, we see E. And we maintain this using an index, right? But the index has to be greater. Maybe we can generate every single subsequence of this word and then check if it's the same as this, right? So maybe we can do like def recursion, need an I, need some sort of cur, I think. If I is greater than the length the thing is here, how do we know? I don't think there's any constraints, so we don't know which one it'll be. Okay, let's do, okay, well, I guess we could kind of do if the length of text 1 is greater than the length of text 2, then we would call recursion 0 cur. Then I don't know if this will work, but my body's so sore, man. Let's do string is equal to text 1, right? And then we can pass in string as well, right? Else we make, so this would be either if they're the same or text 2 is bigger. Recursion 0 cur string, right? And we do, okay, well, if the length of, if the length of I is greater than the length of string, right? Then the length of string minus 1. Right, then we can do res.append cur.copy. We return, right? We need obviously a res array. So let's create that. We loop through this. We check, okay. Okay, so we need to obviously do a cur.append, right? So cur.append string I. Then we call recursion on I plus 1, passing cur. Obviously we need the string. Then we do a cur.pop, and we pass in, okay, recursion I cur string, right? So we would skip that value, okay? Let's print our res. Maximum depth recursion. Maximum recursion depth exceeded. Why are we getting that there? I think this looks good. Why are we getting maximum recursion depth exceeded? I feel like it's gonna be something stupid. Actually, it's not correctly terminating its string. This line is the issue. Oh shit. Okay. It's because I'm doing it on I again, so we're doing the same thing every time, right? So we're meant to just do I plus 1. A, B, C, D, E, ABC. All the so it should generate everything. Okay. Now the brute force method would be, okay, well now we gotta select. Now we gotta see, well, now we do, okay, well, for I in range length, res. String 2 is equal to text 2. So string 2 is equal to text 1. I in range length, we check, okay, well, if, let's change this to a set. Okay, right, so now we check, okay, well, if, if I in set, if I in res, then we get the length. So we need some sort of max variable. So let's do like max length is equal to 0. I in res, we take the length is equal to the length of I. If max length is then we take the max. Let's do that. Let's do max function in Python max. Sorry, max length is equal to the max of max length. And then length. And then we would return our max length. Return max length. Unhashable list. Oh, we can't have shit. Okay. I think that's because I think you can't hold lists inside of list immutable and unhashable, so Python sets and dictionaries can't contain them. Yeah, that's okay, that's what I thought. So this actually needs to be an array, a list. Switch that back. Let's do fine. For I in range length s, all right, we need to check, well, if I, this is not going to work actually now that I think about it, because we're going to loop through the res array, right? And we're going to check, okay, if I in yeah, I know this part's incorrect. I in res, if I in string 2, then we take the length of I, and we do the max, then we do max length, equal to max of max length, and the length of I. Alright, and then we want to return our max length. I still don't know if this would work. I think there's something else that needs to be done here, but... Okay. Then we take the max and we update the max length, right? F is subsequence. Right, we pass in cur, and we would need find cur if cur if cur I in God, this solution is gonna be so slow. I in range length cur. We check if cur I think we're gonna need a J too for J in range length cur. If J, if cur I equal to string J. Probably need a J out here, then we make then we start at trying to think here. If we loop, we check if they're equal. Start is equal to J. J plus 1, right? Because we're at J, right? We're at J, and then we want to go to J plus 1, right? Then we have to do it before. We have to check, well, if J is equal to the length of I, J is equal to the length of cur, then we know this is a substring, right? So then we can just return true. Otherwise, I believe we can just return false over here. So now we know that's a substring. If it's substring. I think we need string 1 in here, actually. Text 1 is greater than text 2. That string is equal to text 1, right? We generate all the subsequences of string 1. Right? And then we want to do, okay, well, and now we want string 2, not string 1. Index is out of range. Cur I. There's a logic issue. What's my logic issue? You're mistakenly scanning cur instead of string. Length of string. Wrong range. Okay, yeah, we're checking the string. J is an index string, not cur. If J is equal to length, that doesn't mean anything relevant here. It's mission check if the character was not found. If any character in cur is not found in order in string, we must return false. Cur is not found in order in string. Start is equal to J plus 1, right? Found is equal to true. Okay. You break. Okay. Then we go here. We go outside of this for. Okay. If not found, right? We return false. Otherwise, we get through this loop. We return true. That makes sense. Okay, so we're checking the found flag. Okay, now we got the brute force solution. Okay, so we've brute forced it. Now we need to add some DP to this. Okay. Now, how can we add DP to this? Build a 2D DP where dpij represents the length of the longest common sequence between. Damn, so if I go, then I'm still dreaming. Base case, if we reach the end of the string, return 0. Oh man, my back. Oh. Characters match, we include the character in the LCS. If I text 1 I is equal to text 2 J result signal.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve longest common subsequence, a dynamic programming problem. And this is pretty much one of the most popular dynamic programming problems. So we are given two strings, text1 and text2, and we just want to return the length of the longest common subsequence between these two strings. And you might remember from my last video where we learned basically what a subsequence is. It's basically you take a string, right, like this string A, B, C, D, E, and you just, you choose a few characters from it while you maintain the order. So one subsequence from this string could be A, B, right? You take the first two characters from it. You can take any characters, you can choose to remove any characters, you can do whatever you want. And so we're looking for the longest common subsequence. So a subsequence that is in both of the strings. So in this example, we have two strings, right? A, B, C, D, E, and A, C, E. So what is the longest common subsequence between these? Well, when you take a look at the first string, you see that, hey, they both have an A, right? They both have an A in the first spot, so that's good. So now let's look at the second character, B and C. Well, this has a B, but the second string does not have a B. But the second string does have a C, and we also have a C over here. But the second string does not have a D, right? So we can't include the D from the first string, but then we see the last character is an E, the last character in the other string is also an E. So we get the longest common subsequence to just be the original second string, right? Ace, because ace can be found in the first string. All we have to do is remove a couple characters, right? Remove the B and remove the D. Then we get a subsequence that matches the second string. So the length of the longest common subsequence is 3. So how can we solve this problem? Well, as I mentioned, dynamic programming is the most efficient way to solve this problem. But before we even get into the dynamic programming solution, which is going to be a two-dimensional dynamic programming solution, before we get into that, let's just notice one thing. So let's say these are our two strings, right? String 1 and string 2. Does it at least make sense to you that, okay, like we would want to start, let's say, at the beginning of both strings, right? Like we're looking for the longest common subsequence. It might just be that both of the strings are actually equal, right? That could be a possible way. So let's look at the first character in each string. And in this case, they match each other, right? They're the same character. So does it at least make sense to you that if both of the characters match each other, right, the first characters, that the longest common subsequence, then we can break it into a sub-problem, right? Now, the new problem we're looking at is finding the longest common subsequence between the remainder of both strings, right? Plus 1, because we see that the first two characters are equal, right? That's where our 1 comes from, right? Because we know that the longest common subsequence is at least going to be 1 because we found a matching pair of characters, right? And then we have a sub-problem, right? And you might know that that's what dynamic programming is all about, finding the sub-problem. Now, what if this character was a B, right? And this is an A, so clearly they're not the same character. What would we do then? Well, we can't do what we just did. We can't add 1 and then find the longest common subsequence between the remainder of the two strings. We can't do that. But we can break it into a different subproblem. We can say, well, it's possible that the longest common subsequence could be between these two strings, right? Or it could be between this string and this string. So this is just a little bit of an explanation before I show you the actual dynamic programming solution, right? Basically, what we found out is that based on comparing the first two characters, whether they're equal or not equal, we can break up the problem into sub-problems and then solve those sub-problems. So
make a decision.
So take a look what I just did. I took the two input strings, right? String 1 and string 2, and I wrote them in a different way, right? I said that this is a two-dimensional dynamic programming problem, and you might know that a grid, a 2D grid like this, is commonly used to solve these types of dynamic programming problems. So notice that for each character in both strings, there's a square, right? A position, a cell that we can put a value in. We're going to put a value in each of these cells. And so let's just start at the beginning like we did, right? So let's start at the first characters, right? What we're trying to do is for these strings, find the longest common subsequence between the entire strings, right? So what we're going to do is put that value right here. That's what's going to be the entire longest common subsequence. So we want to compute the value that goes here, but what you're going to find is to do that, we need to solve some subproblems and then, continue to do that and then work our way back up to this position. So what do we notice? Let's look at these two characters, right? They're equal, A and A, right? So, okay, so now we want to find the value that goes here. How can we find that value? Well, like I mentioned, right, now we're trying to solve a subproblem. We want to find the longest common subsequence between these two substrings, right? We don't have to check these A's anymore because we know they match each other. So now I want to find this new subproblem, right? And so basically what I'm saying is I'm going to go here. I want to solve the subproblem that goes here. So now we're here, right? We're comparing this B with this C. We see that they're not equal this time, right? That means we're not going to be going diagonally. We're not going to look at this subproblem. We're going to look at a different subproblem. Since these characters do not equal each other, we have to check two different subproblems. It means that the longest common subsequence between these two substrings is going to be found in either of these two positions, right? So let's look at this position first. What this position tells us, we're trying to find the longest common subsequence between this string and this string, right? So basically we're not looking at this C anymore, right? And this position tells us that we're looking at the longest common subsequence between this string and this string. So basically when we remove this B, right? And just by looking at it, right, you can tell that this is going to, these two strings are going to lead to a longest common subsequence of 1. Just by looking at it, right, because you can see that this has one character, it's an E, it only matches this E, so that's going to be a 1. But when you look at this string and this string, right, corresponding to this position, we see that this has a CE, this has a CE, so this is going to end up being a 2. But let me actually solve the rest of it a little bit. So mainly looking at these two strings, right, in this position, we see that the C's match each other, right? So since, remember, when the characters match each other, the first characters of both strings match each other, that's when we go diagonally. And the reason we go diagonally is because then we know we can look at the remainder of both of the strings, right? We know that this C matches this C, so we want to look diagonally. We want to look at these two substrings. So what's the longest common substring between these two? Okay, so what are we going to do? Let's compare the first character, right? So D and E. So these characters are not equal. So remember what we do when the first characters are not equal. Then we can't go diagonally. So what do we decide to do? We go to the right and we go down and we take whatever the max of these two is and then put it in this value. That's what we're gonna do. So first, let's check this right position. So what does this right position even mean? It means we're taking this substring and finding the longest common subsequence with this substring, but this is an empty string. So what's gonna be in this cell? Remember, this is actually out of bounds anyway, right? So what default value are we gonna give ourselves if we go out of bounds to the right? Clearly, the longest common subsequence between a string and an empty string like this is going to be 0, right? So really, what we're going to initialize is we're going to say every value in this column is going to be 0. Similarly, this is an empty substring. If we were trying to find the LCS, the longest common subsequence between this and an empty substring, we would also get 0. So what we're going to do is put a 0 in these positions, right? That's just how we're going to initialize our 2D matrix when we start the problem. Okay, so remember what we were doing. We were at this position, we were going right and we were going down trying to find the maximum value. Well, clearly to the right we get a 0, so that's not the max. So let's go down. Okay, now we're down. So what are we doing? We're finding the LCS between this substring and this substring? Well, they're the exact same, right? E matches E. Okay, great. And remember, when characters match each other, that's when we look diagonally, right? So we came down here and now we're looking diagonally. Clearly, we get a 0 here, right? So 0 plus 1. The reason we're doing a plus 1 here is because we found matching characters. When characters match, we add 1 because clearly the LCS between these is going to at least be 1, right? At least one of these characters matches. So now I'm basically going to go here and then take us back along the path that we came from and then show you what the solution is. So we had a 1 here, right? And so from this position, we went down. So since we were going down, that means that this character and this character did not match each other. So what we're going to do is just take the 1 and put it up here, right? So there's going to be a 1 here because the LCS between these two is 1. But now we're going to go back over here diagonally, right? Diagonally means that this character matched this character, right? So we're going to take the value that we got up here, put it over here, and add 1 because remember, these match each other. So we're adding 1. That means we're going to end up putting a 2 in this position. And now we're going up, right? We're going up because that's where we came from. And remember, when you go up, that means the characters did not match each other. The C and the B don't match each other. So we're going to put a 2 here, right? We're just taking this 2 and putting it over here. And lastly, we're going back here. That's where we came from, right? Diagonally. That means the characters were matching each other. So we can add at least 1 character. So 2 plus 1, that's going to be 3. This is how we got the result, right? So we got a 3, meaning that the LCS between these two strings is 3, right? And that's what we learned from the problem explanation. So, right, what we're going to do is return 3. That's our result. But you can see that the way I did it was basically intuitive, right? I used this picture and basically solved this problem by hand using a little intuition and stuff, right? But the way we're going to have to solve this with code is going to be brute force-ish, right? So it's dynamic programming, but what we're going to have to do is for every value in this cell, right? So we are going to initialize these zeros, right? But with this matrix, right, this 2D matrix, we have the value that goes up here, right? And to do that, we have to compute the value that goes here, that goes here, that goes here, and basically for all these, and then finally we'll be able to have the value that goes here, which is the result that we're going to return. And so basically what I'm saying is this is going to be a bottom-up dynamic programming solution, right? Bottom up, meaning we're going to solve it in reverse order. We're going to first get every value. We're going to get the value that goes here and then work our way up until we get to the result. And you might have noticed, see, I have an I that tells us the column. I have a J that tells us, actually the column, and the I tells us what the row is. And so when we're working our way, starting at the bottom and then working our way up, how are we going to determine what value goes in each cell? Basically what I went over earlier, right? So we're going to look at the characters, and if they match each other, what we're going to do is say 1 plus the value that's diagonal, right? And we know when we go out of bounds, there's a 0, right? There's an implicit 0 when we go out of bounds. And we're going to do that with every single cell, right? So when you look at these two, we get an E and a C, right? And when characters don't match each other, right? That's important. What we're going to do is we're going to look down, right? We see a 0 down here, and we're going to go right to the right side, and we see a 1 here on the right side. And what we're going to do is take the max of those two values, and we see that the max is, of course, 1, right? 1 is bigger than 0, and then we're going to put that max value in the cell. So that's really it. There are two choices, right? If the characters don't match each other, right, in this case, or if the characters do match each other in this case, right? That's basically how we're going to solve this problem. It'll make a little more sense when I show you the code. So remember, we're going to have a 2D grid. So I'm going to call that DP for dynamic programming. It's going to be a 2D grid. And what I'm initially going to do is set it to all zeros, right? So, and I'm just going to do a little bit of Python stuff. So list comprehension in Python. So we're going to go through every single value in the length of text 2 plus 1, right? Plus 1 because we know that we need at least one more column to have all the zeros in it. And so remember, we're going to put a 0 for every value in that. So length plus 1. And and we're going to have this row for every value in the length of string 1, so text 1 plus 1 as well, right? So we're basically, if you're not familiar with Python, this looks complicated, but basically we're getting a 2D grid of dimensions length 2 plus 1 times length string 1 plus 1 and initializing it to all zeros. And then we're just going to have a nested loop. And what we're going to do is iterate through this 2D grid in reverse order. So in Python, you can do it like this. And basically what I'm doing is starting at the bottom right of the matrix and then working our way up. So this is how you do it in Python, -1, -1. And let's do the same thing for text 2. And so remember, so we're going through every cell in our 2D grid. And remember, there were two conditions. One condition is if the characters in both strings match each other. So if text 1 of I matches text 2 at position J, if they match each other, we're going to do something. And if they don't match each other, we're going to do something different. So remember, if they do match each other, then what we can say is at this position, dp of ij, because remember, we're trying to fill in every single cell, what we can do is then just simply take 1 plus the diagonal. How do we find the diagonal? Well, we can say I plus 1 and j plus 1, right? That gives us the diagonal. And remember, we're adding 1 to it because these characters match. That means we add a 1. And if they don't match, that's the else case, right? So we're doing something different here. We're going to put a different value for dp of ij. And in this case, what we're doing is we're finding the maximum of two values. What are the two values? The value to the right of this position. So we can say dp of I, j plus 1. We can say that's the right value, and the value below, the bottom value. So we can say I plus 1 and j for that, right? So we're finding the maximum of these two. We're not adding 1. We're not adding 1 because the characters did not match each other. But basically, literally, these are the two cases. We're just filling in a different value depending on what the case is. And that's it. So literally, with these two nested loops and with these two conditions, we're filling in the entire DP matrix. And so once that matrix is filled in, we know that the result is going to be at the top left of that matrix. So the DP, the matrix at index 0, 0. That's going to have our result. So all we have to do now is return the result. And clearly you can see that the time complexity of this is the length of the strings multiplied by each other. So if the length of string 1 was n and the length of string 2 was m, we just multiply them together. So this would be the time complexity. That's also the memory complexity because we need extra memory for our 2D dynamic programming grid. Oops, I had just one little bug. I added one to the inside of that function, but I need to add one here. But other than that, you can see that the code does work, and it is pretty efficient because the dynamic programming solution is the most efficient for
Yeah, this is a really interesting solution. I would have never thought about this. Like, bro, this is crazy. Let's put this over here. Try and code this up ourselves. So this is the brute force solution using recursion. Brute force. Oh my gosh, dude. All right. Let's get rid of this. Okay. So now we need to develop our list, right? So we can do our grid is equal to for I in range length text 1 plus 1. for I in range. Let's see, sorry, for J in range length. Oh my god, dude. Get rid of this. Yeah, don't show again, bro. Go away. Bro, what is going on here? Range length text 2 plus 1. We need to put 0 somewhere. 0 for I in range length text 1 plus 1. Plus 1. 4J in range length text 2 plus 2. Let's print out grid. Okay. Now we need a loop. Okay, for I in range length. Range length text 1. Minus 1. Looping backwards, right? For J in range length text 2. Minus 1. Minus 1, minus 1. Yeah. Okay. Now, in the way that they checked it here, we need to check, okay, well, do an if statement here. If DP I J oh, jeez. If DPIJ, bless me, DPIJ DPIJ is referring to the value in there, but we don't have any value in there, so how? Okay. If text 1 I equal to text 2, that's why we need text 2 I, right? We need to compare here, right? So we would go, okay, well, you know, DPIJ is equal to 1 plus DP. We need the value before it, right? Because we're looping in reverse here, right? We've got this here. We're looping in reverse. Okay. So we're starting here. Technically, we're starting here. This is nothing. We go here. We're at here. We would need to check DP plus 1. I think it's DP plus 1. DPI plus 1. DPJ plus 1, right? I think that's correct. Let's take a look. It is. Okay, else, what we need to do, right? Else, we would... What are we doing now else? I don't remember. If they're not equal, we move ACE. If they're not equal, we would move down or we would move right, I think. I think we have two choices, huh? Let's read.
ij, because 1 and j plus 1, right? That gives us the diagonal. And remember, we're adding 1 to it because these characters match. That means we add a 1. And if they don't match, that's the else case, right? So we're doing something different here. We're going to put a different value for dp of ij. And in this case, what we're doing is we're finding the maximum of two values. What are the two values? The value to the right of this.
Okay, yeah, that's right. We want the maximum value of either from the right, which would be dp I plus 1 j. We need the max. dp I 1 j. Or dp I j plus 1, I think.
This position, so we can say dp of I, j plus 1. We can say that's the right value, and the value below, the bottom value. So we can say I plus 1 and j for that, right? So we're finding the maximum of these two. We're not adding 1. We're not adding 1 because the characters did not match each other. But basically, literally, these are the two cases. We're just filling in a different value depending on what the case is. And that's it. So literally, with these two nested loops and with these two conditions, we're filling in the entire...
Right, and then we'd want to return dp 0, 0, right?
Entire d at the top. That's going to really, you can multiply by each other. So if the
Texu j dp ij equal to 1 plus dp I plus 1 j plus 1, else dp ij is equal to the max of dp I j plus 1 or dp I plus 1 j. Turn dp 0, 0. Why does this not work? I actually have no reason. Oh, forgot a comma here. Whoops. Next is out of range now. What? What? There we go. What is the memorization solution? TP solution, right? Let's do the memoization solution, right? I feel like memoization is more like intuitive for me. Like this DP, but it's tough. I'm gonna keep getting better though, but let's do def recursion ij, right? Recursion function recursion 0 0, right? Now base case, well, if I is equal to the length of text 1, j is equal to the length of text 2, right? We want to return 0. Okay. If ij in memo, we want to return memo ij, right? So we're taking that point in the grid, and we know where we're at, like how much this adds up, right? Okay. So then we want to check, well, if text I is equal to text j, right? Then we want our result to equal to 1 plus helper, go to the next value, I plus 1, j plus 1, right? Else, if it's not, then we're doing the same thing. We want the max, right? But we're taking the max of either I plus 1 recursion, the next value, recursion I plus 1 j, or recursion I j plus 1, right? Okay. Otherwise, memo ij is equal to result, and we return result. Return recursion. Memo is equal to dictionary. Text is not defined. Did you mean text? Text 1i, text 2j. Helper is not defined. Meant recursion. Okay. It's hard to think about these problems, man. I don't know. Anyway, okay, we'll be back. I have to go to the bathroom. And then we'll continue some more problems. Yeah, we'll be back in a second. Okay, we're back. I gotta go to work in about half an hour. And I said yesterday, I promised that we would do a graph problem. So I'm gonna take a look at another graph problem. I want to do a DFS problem. So let's take a look at one. Maybe we can look at one we've done before, or you know, something. We've got about, literally got about half an hour. So topics is, we want depth first search, and we want graph. Maybe get rid of that first. Let me just do graph course schedule. Man, I want to get Leetcode Premium so I can do some of these other questions. Like, couples holding hands, network delay time, redundant connection. This is just a classic DFS problem. I've done this a few times, I think. Yeah, a few times. Total number of courses you have to take, level 0 to n num courses -1. You're given an array of prerequisites or prerequisites I is equal to A1, B1. Wait, when did we do this? April 21st. About 3 weeks ago. In case you must take course B1 if you want to take course A1. B1 if you want to take A1. It's not true if you can finish all the courses, otherwise return false. Okay. We have to create our adjacency matrix, right? So let's do def graph. Pass in our prerequisites, right? Want to initialize our graph in here. Okay. We want to do graph is equal to graph prerequisites. Right. Let's do so it is impossible. I have to understand this problem properly again. Total of 2 courses to take, right? We have 1, 0, and 0, 1. So to take course 1, you need to take course 0. Take course 0, you have to take course 1. So it is impossible. Okay, so if AB is equal to edge, right? If A not in graph, then graph is equal to graph A is equal to this. If B not in graph, then graph B is equal to this. Graph A dot append B. But we have to do it the other way around, right? We'd have to go, okay, graph B, because to take course A, you have to take course B. So it would be graph B is A. Right, and then we'd want to return our graph, right? Let's print our graph. Def DFS. Alright, we need probably a node that we're at. Right? Okay, an I. And we're gonna need a visited. Okay, let's start with that, right? So okay, I think we're gonna need to num courses 2. For I in range length num courses. Sorry. I need to think, how am I gonna solve this, dude? So we start here, we can go to 1. We're visited at 1, right? Then we call DFS on 1. If we've already visited something, then we're fucked, right? So let's do, okay, so if, let's make this node. If node in visited, okay, we're gonna say you want to return false, okay? If for node in graph node, let's see, for neighbor in graph node, we want to do, well, if recursion, if DFS neighbor visited we want to return false, right? I want to do visited.add node. Otherwise, I guess we can just return true, right? For I DFS I visited. We need like a visited array. Visited is equal to set, right? If DFS, if I not in visited, then we can call it again, right? If not DFS I visited, then we can return false. Otherwise, we can return true. Range length, courses, -1. Oh shit, we don't need a length. Whoops, courses is an integer. What am I doing? Let's run it. Shit, did that work then? No way I solved that quick. That's what I thought. Okay. Key error for neighbor in graph node. Key error for neighboring graph node. Maybe that node doesn't exist. I think what this error means is that if what I'm thinking is that there's no values at this key, or this key doesn't exist. It's one of the two. Oh, I need to pass in out graph. Is that why? Graph. ADJ matrix. Okay. Visiting. Visiting.add node, right? Then once we get to the end, we do visited.add node. Oh, whoops. Need a set here. Maximum recursion depth exceeded. Visited. Return false. Does this work? Need to. Oh, passing a new empty visited. Doesn't this do the same thing, bro? Visiting. I'm still getting this key error, dude. Like, I swear that's the same thing. Also, update your DC mesh function. Initialize all num courses in the graph, even if they have no prerequisites. Is that my key error the whole time? For I in courses. Jeez, man, how did I do the other ones? If node and visited, return true. All right, we're gonna call it there. I had some problem with my DFS, my keys. I should have realized that at the beginning. Then I probably would have kept looking at it. My back. Oh. But yeah, I appreciate you guys watching, and I will see you tomorrow. See you guys later.